Welcome to section 8.2. In this section, we're going to focus on just examining the graphs of nonlinear functions and seeing what their basic shapes look like. Now, before we do that, I do want to review square roots real quickly because we are going to use some square roots in here. Alright, how do you take the square root of a number? That's the opposite of squaring a number. So, for example, because 4 squared equals 16, the square root of 16 is 4. Now, this is interesting right here. Negative 4 squared is also 16 because negative 4 times negative 4 is 16. But the square root of 16 does not equal negative 4. The square root of 16 is only defined to be the positive root. Okay, square root of 16 is never going to equal, a square root of a number will never be a negative number. So therefore, the square root of 16 is not negative 4, it is 4, and only 4. Okay, what if you wanted to find the square root of negative 16? Can you think of a number whose square equals negative 16? Now your answer should be no, not a real number at least, because any real number, if it's a positive number squared, you get a positive number, not negative. And if it's a negative number squared, you also get a positive number, not negative. So this is undefined. There is no real number such that its square will ever be negative. Okay, so square root of 36, you ask yourself, what number squared equals 36? You should know, that is 6. Square root of 4, 2 squared is 4, so that is 2. Ooh, fractions, the square root of 1/9. What number, when you square it, do you get 1/9? Well, you have to think in terms of fractions here. 1 squared is 1, so the numerator will be 1. And what number squared equals 9? 3. 3 squared is 9. So if you square a third times a third, we can even go up off to the side here, a third times a third, multiply numerators, you get 1, multiply denominators, you get 9, so that is correct. Now this one's interesting, you have the negative of the square root of 81. Now the negative is really just out here in front of the square root, so it just hangs along. Okay, it's not the square root of negative 81, it's the negative of the square root of 81. Well, the square root of 81 is 9, so this is negative 9. And the square root of negative 81, that is undefined because you can't take the square root of a negative number. So I hope that cleared up any confusion you may have had about square roots. Alright, let's go ahead and actually, we're going to jump to x squared first. We'll get to the square roots last in this section. First, I want to graph f of x equals the negative of x squared. We're going to do this and examine what the graph of a squared function looks like by creating a t-chart and plotting points to get a good idea of what's really going on here. Okay, so let's choose some x values, both negative and positive. I'm going to go out to about negative 4. If x is negative 4, really this should say f of x up here. F of x, which is the negative of x squared, let's see, that would be the negative of negative 4 squared. So negative 4 squared is 16, and this negative hangs along, so we have negative 16. Alright, let's go ahead and draw some tick marks in here. I'm going to just use these axes here. Each line is 1. And let's see, if we go down, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 16 is just off the graph right about there. So when x is negative 4, right here, y is negative 16, about right there. Okay, let's plot another point. Let's try negative 3. If x is negative 3, we'd have the negative of negative 3 squared. Those parentheses you have to have or it's not correct. So that would be the negative of negative 3 squared is 9, so negative 9. So when x is negative 3, y is negative 1, 2, 3, 4, 5, 6, 7, 8, and 9, right about there. Now I want to get a better graph. We need to see what's going on, so let's do some more. If x is negative 2, we'll have the negative of negative 2 squared, which is negative 4. So negative 2, negative 1, 2, 3, 4. Okay. If x is negative 1, we'd have the negative of negative 1 squared, which is negative 1. So negative 1 is on the graph. If x is 0, we have the negative of 0 squared, which is 0. Okay, so starting to see some patterns here emerging. If x is 1, we'll have the negative of 1 squared. Now, here you apply the square first and only to the 1. 1 squared is 1. Then we multiply by the negative. So we have negative 1. So when x is positive 1, y is still negative 1. If x is positive 2, we'll have the negative of 2 squared. Now remember, you apply the exponent first. So that's 4. And then that negative out front gets multiplied out. So we have x is 2, y is negative 4. When x is 3, y is going to be negative 9. When x is 4, y will be negative 16. Okay, and if you plugged in any decimals or fractions in between any of these integers that we chose, it would fall, the point that you would get would fall in line with these. So this is enough to get an idea of what the basic shape of this is called a quadratic, as you know, what the shape of a quadratic's graph looks like. Now this is called a parabola. The basic shape here, how it has that curve to it, that's called a parabola. You're going to see lots more of those coming up in this course. So graphs that have x squareds in them tend to have the shape of a parabola. They don't always look exactly like this, but they have that sort of curve to them. Some open up, might open like that. Others open down like that. Some might be wide. Some might be really, really skinny like this. Depends on the numbers. Okay, now if you're unsure about what the graph looks like, the graph of a nonlinear equation, you should plot more points. Okay, until you learn what their graphs do look like and you learn what to do, until then, plot more points until you get a better graph. Okay, to make sure you get an accurate shape going on. Let's do another example. Let's look at the graph of the absolute value of x plus 1. So again, let's make a t-chart here. Okay, when x is, let's go with negative 4. Now remember, absolute value makes everything positive. So the absolute value of negative 4 is 4. And then we add 1 to that, so we get 5. If x is negative 3, we have the absolute value of negative 3, then plus 1, which is 3. Oops, I should say equals 3 plus 1, which is 4. If x is negative 2, I get 3. If x is negative 1, start to see a pattern here, 5, 4, 3, 2. If x is 0, absolute value of 0 is 0, of course, plus 1 is 1. If x is 1, the absolute value of 1 is 1, plus 1 is 2. If x is 2, the absolute value of 2 is 2, plus 1 is 3. So it looks like the numbers are going back up, and I think I have plenty of numbers here now to plot. So when x is negative 4, we get y is 5. When x is negative 3, y is 4. When x is negative 2, y is 3, and so on. So connecting the points, you can see that this graph, interestingly, has what's called a V shape to it. And pretty much all of your absolute value graphs, not all, but if it just has an absolute value of a linear function like this one, it's going to have a V shape to it. Absolute value graphs tend to have V shapes. So that's the graph of f of x there. Alright, and let's do one more now with the radical, the square root of x minus 1. So again, let's do a t-chart. see what this graph looks like. Okay, let's try again. Let's try -4. So if we do f of -4, we'd have the square root of -4 minus 1. What's the square root of -5? Which is undefined. You can't take the square root of a negative number, so there is no y value when x is -4. There's just nothing on the graph when x is -4 out here. Okay, and as you can see, if I was to plug in -3, I'd get the same thing. In fact, let's try -1. If I plug in -1, I still have the square root of -2, still undefined, so it still doesn't work. Let's try 0. If I plug in 0, I still have the square root of -1, still undefined. Let's keep going. Let's plug in 1. If I plug in 1, I have the square root of 1 minus 1. Square root of 0 is defined. The square root of 0 is 0. There's our first point on the graph finally. When x is 1, y is 0. Now let's try 2. We'd have the square root of 2 minus 1. Well, it's the square root of 1, which is 1. So when x is 2, y is 1. And now here's where you have to start watching, because you may have to use your calculator if you choose difficult numbers. Because, for example, the square root of 3, if I choose x to be 3, I get square root of 2, which you may or may not know offhand what that is. I know it's close to about 1.4 if you round that on your calculator. So let's go with 3, about 1.4. You don't have to choose messy numbers like that. What you may want to do is just choose numbers that have even or whole number square roots. For example, I know the next square root will be the square root of 4. The square root of 4 is 2. The only way to get 4 there is to choose a 5. So if I do x is 5, I'll have square root of 5 minus 1, which is the square root of 4, which is 2. So I'm going to jump out to 1, 2, 3, 4, 5, 2. We'll just skip plotting x equals 4 because we can get a good graph without it. In fact, this is pretty good as is. You can see the graph has sort of an interesting curve shape. And what's really interesting is there is no graph way out here because you cannot take the square root of a negative number. So the domain on this function is rather interesting. Remember, domain is the set of all the x values that you can plug in. Well, the first x value that we can plug in is at 1 here. And if you plug in any decimal just slightly less than 1, even if you plugged in 0.099, right, you would get the square root of -0.01, which is undefined. So the very, very first real number value that you can plug in is x equals 1. So the domain goes from 1, and then any x value bigger than that you can plug in, you'll get a real number. So from 1 to infinity is the domain of this. So radical functions, this is called a radical function because it has that radical there, tend to have domains that are not just all real numbers. So on these previous two examples, such as this one, so you can plug in any x here, right? You can take the absolute value of any number and then add 1 to it. So on this one, the domain is all real numbers. And on this one, you can plug in any number, square it, and take the negative of it, and that will happen. So the domain here is also all real numbers. It's just radical functions that tend to have what I call domain issues. Well, that's it for 8.2 because we already talked about or reviewed functions previously before we did Chapter 7, which is the other part of 8.2. Next, we're going to go into 8.3, which is a little bit more about graphing nonlinear functions and looking at how do you graph them without plotting points. And then we'll look at piecewise functions.